we're going to look at solving trig equations in some simple steps, which I'll walk you through. If it's a simple angle like this one here, that's just a theta, then we're just going to use 3 simple steps. If they're more complex, like this, say a double angle, or we're adding something to the angle, then we're going to use 5 steps. Question 1. Solve 3 sine theta equals -2 in the interval theta is between 0 and 4 pi. Now, for simple trig questions like this, there are only 3 steps you need to follow, and I encourage you to memorise these. The first step is the angle, second graph, and third step theta. So let's have a go. The first thing we want to do is isolate the trig function. So whatever it is, sine, cos, tan, get rid of anything else. So in this case we have a 3. Let's try and get rid of that 3 by dividing both sides by 3. Right, now we want to find the angle. So we have our basic equation that we're solving. Now to find theta, we're going to take the inverse of -2/3. If you pop this on your calculator, make sure you're in radians. If the question is in radians, then you want to make sure your calculator is also in radians. So we have -0.7297. We're going to use a trick now to make sure we don't get any rounding errors. We're going to use our calculator and we're going to use a store function whereby we're going to store this value, but it's going to be the positive value. So when you see this on your calculator that it's negative, times it by -1. Then use your store button to store this as A. So A will be 7297. Let me just show you how to do that to make sure you're happy with that. Depending on which calculator you have, if it's the class whiz, you're going to use this button, the STO. So once you've times it by -1, press this button, then press A. No need to press alpha, so if it's A is up here, just press store, then directly this minus button. Or if you're on the graphical, you're going to use this arrow. Notice that we're using this arrow notation in our working as well. So we're storing this button, and then press A. And that means you never have to enter that value into your calculator again. We're going to use it quite a bit to find all our solutions, but this way will make it much easier. Right, we're ready to plot our graphs now. So the first thing we're going to do is plot y equals sine theta. We're also going to plot the graph y equals -2/3. Let's have a think about why we're doing this. We're trying to solve this equation here. So if we plot the graph y equals sine theta and the graph y equals -2/3 and look at their intersection points, the x-coordinate of those intersection points will be the solutions to this equation. The third thing we're going to do in this step is we're going to show the distance A. And remember, we stored A as positive, so that will be a distance. You can't have a negative distance, hence we always make sure A is positive. We're going to plot our graph now. So our sine graph starts at the origin. Remember, we're going to 4 pi. Next, we're ready to plot our second graph. So we're plotting now y equals -2/3. So about there, and it's going to go about to there. So now what we're looking at is all our intersection points. So we can see we've got 4 intersection points within this domain. But again, like I say, we're not interested in the coordinates, we're interested in the x values. So let's take these intersection points, and just to remind us that we're trying to find out the x coordinate. Now why don't we call them theta 1, theta 2, theta 3, and theta 4. I'll just label this, so this is minus 2 over 3. Next, we're going to show this distance. Now, remember we got that distance, it was a negative initially. Why was it a negative? Well, what your calculator's doing is it's saying, well, when does this sine graph intersect this line y equals minus 2 over 3? Now, it could have given you this one, but actually it tends to give you the one closest to 0. So if we extended the sine graph down back the way, your calculator's just saying, well, I'm going to give this solution here. So the line would intersect like that, and it's giving you this value here, which is minus 0.7297. So we know that distance from that point back to the origin, because the x-coordinate here is minus 0.7297, the distance, remember it's positive because it's a distance, is 7297. We'll call that A. Well, where else does A occur? Well, there's the intersection, and we're coming down, so that distance correlates with this slope here. Well, I can see another place where there's that slope. It's the reflection, but it's exactly the same because symmetry in the sine graph. So we have another place from pi up to theta 1. That's also A. I know they look different on my graph, but obviously it's not to scale. Likewise here, so going from this point to 2 pi, what about here? Well, there's that intersection, there's that slope just there, exactly the same as that slope there, and that correlates with this distance on the x-axis, just like this distance on the x-axis is also going to be A. So I'd encourage you first to find your intersection point. Just like there's an intersection point here, go along to A. Here's our intersection point, go along this way. That's going to be our A value. Our third step, theta equals, well, we know we've got 4 values, so I'm going to write those in because I want to make sure I'm not creating extra answers, because obviously there's going to be an infinite amount of answers here, but we're only interested in 4 because those are what are in our domain. So the first one is going to be pi plus A. The second one is going to be 2 pi here minus that distance. So it's going to be 2 pi minus A. Theta 3 is going to be 3 pi plus A. And theta 4 is going to be 4 pi minus A. I hope you can see a pattern here. It's useful to see so that you don't make a silly mistake. So we've got theta plus 2 pi minus, 3 pi plus 4 pi minus. And you can guess that the next one's going to be 5 pi plus. The odd numbers are correlated with a plus and the even numbers with a minus. Some students choose to just memorise that pattern for sine. It's always the same. Right, so hopefully you can see now why we stored that value A in our calculator, because this allows us, we're not messing around with lots of really long numbers here, likely to make a mistake. And it's only in the last step where we can just put in pi plus A on our calculator, and you should find that's 3.871. We'll go to 3 decimal places here. Remember, to find your stored value, you're going to have to press alpha first. Alpha and then A. So 2 pi minus will give you 5.553. 3 pi plus, you're going to get 10.155. And last answer, 11.837. Question 2. Now for these types of questions where we have not just a theta, but some multiple, or maybe it's plus pi, some angle that's not just one variable. There's going to be a 5-step process to this. So the first thing you've got to do, like always, we're going to try and rearrange this whole thing so that we've got just one trig function equals a number. Next we can say 2 tan 2 theta, remember tan is sine over cos, keep the angle the same, equals 3, or we can, remember we want to get rid of this 2, we just want it a trig function on the left hand side, equals a number. So tan 2 theta equals 3 over 2. This is what we're trying to solve now. So that's our question, rather than this thing that looks really complicated. Now this is something we can tackle. So the first step is to let our angle equal u. So this we're going to let u equal 2 theta. Therefore, we have tan of u equals 3 over 2. If we want to find u now, we're going to take the inverse tan of 3 over 2. Notice what we've done here, we've simplified it. We've gone from this thing here to this, which is dead simple. Tan of an angle equals 1.5. So if we put this into our calculator, we're in degrees, make sure your calculator's in degrees, you should get 56.3099. Now we're going to do that trick again. We're going to store this value in our calculator. So on our calculator, we're going to store this value as a. Check that it's positive, because we're going to use a as a distance. Now we're going to the second step. We're going to work out the new domain. So first off, the old domain is between 0 and 360. Now to find the new domain, we need to make this theta 2 theta. So we're going to times all of those parts by 2. 0 times 2 is 0. Theta times 2 is 2 theta. 360 times 2 is 720. This is our new domain. So our new domain is going from 0, 2 theta is u, so your new domain has to be in terms of u, up to 720. Third step, we're going to plot y equals tan u, and we're also going to plot y equals 3 over 2. We're going to show the distance a. Okay, we're ready now to plot our graph. So again, a quick sketch, draw your axes, label a few points that can be useful. With tan, we know we've got asymptotes at 90 degrees. Our first quadrant looks something like that. Second quadrant like that. Now we have to plot y equals 3 over 2. So 1.5 could be anywhere. Let's say it's about there. That's going to be at 3 over 2. Now we're trying to solve this equation here, so we're looking for the intersection points between this graph and this graph here. So our intersection points are here, 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 and here. Now we're not interested in the coordinate, we want just the x coordinate there. Let's call these angles, so remember that we're plotting the tan U graph, so this axis is going to be U. Let's call these values U1, U2, U3 and U4. Next we need to show the distance A on our hour graphs. So let's have a look here. It crosses the x-axis and then it curves upwards. That curve there is correlated with a distance here, which is A. That's our 56 degrees. So let's mark that on there. Next, let's try and find where else does A appear. Well, let's look, where else does it cross the x-axis? It crosses at 180, curves upwards, so that curve there is correlated with this horizontal distance, which will also be A. Next, let's look for the other intersection. It crosses at 360, going up to U3, that's going to be another A. 540, that's not a very good, it should cross at 540. Going up to U4, we've got another A. Let's go on to step 4. So we're saying our U equals, well, we've got 4 angles here. We've got U1, U2, U3 and U4. The benefit of doing it like this is you don't have to kind of constantly write it out. U equals U1, it also equals U2. Just write them all in a list like that. Right, so let's write U1 in terms of A. So we know that U1 is A. We know that U2 is going to be 180 degrees plus A. U3 is 360 plus A. And U4 is going to be 540 plus A. Step 5. How are theta and U related? Well, up here we defined U to be 2 theta. Therefore, theta must be U divided by 2. So all we have to do now is all of our U angles, we're going to divide those by 2. So our first angle is going to be A over 2. Second angle is going to be 180 plus A over 2. So notice we're not messing around with any really horrible irrational numbers. That was the benefit of writing it in terms of A. Otherwise I would have had to write out 56.3099 many times and it would have looked a complete mess. Now I can just substitute this into my calculator, use my A, recall it using alpha A on your calculator, and you should find, if I divide A by 2, I'm going to get, I'll do to 3 decimal places, 28.155, 118.155, 208.155, and 298.155. Question 3. The first thing we're going to do is get rid of this 9. We just want some function, some trig function of an angle, even if that angle is a really horrible looking angle like this one is, equals some number. Now we're ready to use our 5 steps because we've already got it in this form. So the first step is to let U equal that angle. So that horrible looking angle, we can let it equal 3x plus 75. That means cos of U is equal to 2 over 9. So this looks much nicer, much easier to plot than this thing here. We know what a cos of some variable looks like. It's just our normal cos graph. Let's find out our principal angle. So we'll take the inverse cos of 2 over 9. If we put that on our calculator, making sure we're in degrees, we should get 77.160 degrees. Now that's a really, that's an irrational number. I don't want to get any rounding errors, so really important here, I'm going to store it as my a, making sure it's positive, which it already is. So that's stored in my calculator. My next step, finding the new domain. Well, the old domain is between 0 and 180. To find my new domain, I need to get this middle, this x, to look like 3x plus 75. So I'm going to times all three of these things by 3 and then add 75 onto them. So I'm going to times 0 by 3 and plus 75 on. I'm going to do the same with x plus 75. And I'm going to do the same with 180. So 3 times 180 plus 75. And if I work those out, I'm going to get a new domain of 75. So 3 times 0 is 0, plus 75 is 75. Now this is just my u. So my new domain is u is between 75 and if I times 180 by 3 plus 75, I'm going to get 615. Now I'm ready to graph it. I'm plotting cos of u, and I'm also going to plot y equals 2 over 9. I'm also going to show a, so the modulus, the positive value of this principal angle. So a quick sketch. So I know 720 is here. I know my graph can't be any results past this point are going to be out of my domain. So this is my cutoff point. Let's now plot my y equals 2 over 9. So 2 over 9, if I put them on my calculator, it's equal approximately to it's 0.2 recurring. So we can plot that. And now I'm looking at all my intersection points. So here's an intersection point here, but I don't care about the coordinate, I care about the x value. So I'm going to draw a little arrow coming down to the x-axis. There's an intersection point there. Let me come down to my x-axis, and likewise here as well. And I'm going to call these, this can be my first angle I'm looking for. This is U2, my second, my third, and my fourth. Okay, so I've plotted this one, y equals cos u, so I've plotted y equals 2 over 9. Now I need to show my a. What is this distance here? Well, it's this distance here. This is what my calculator has given me. It's only given me one answer. This is my 77.16, or my a. And we're going to use that distance. That's why it's got to be positive, because it's a distance. We're going to use this distance to find out all these other angles. So let's have a look at the next step. So u equals u1, u2, u3, and u4. I don't know if this u4 is a solution, because I don't know if it's above or below 615, but we'll find it out and we'll see if it is or not. We'll keep it in for now because we don't want to lose any solutions. Right, so u1 is just a, we can see that from the graph. u2 using symmetry, well, I know this here is 360. And I know that if I come back from my peak, then I've got an a value just here. So let me just show that. So here would also be the same distance, that's a there. So here, this answer here would be 360 minus a. And now to find u3, I'm going to notice that, well, that distance from my peak coming down the way, just like if I was at my peak and I came down, here's my peak and I'm coming down. So that distance must also be A. So my U3 is going to be 360 plus A. And finally U4, well, that's just 720 minus that distance, that A value, which would be there. That would also be a distance A from my peak coming down, just like here I was at my peak coming down. So my U4 is going to be 720 minus A. Great, you'll notice I haven't even started using numbers yet, and that's because I don't want to get into a faff. I don't want to make any mistakes, and I don't want to write out some really long numbers. So I'm sticking with my A's. Okay, so what's theta then? If U is 3 theta plus 75, then theta must be U minus 75, I'll write it down here, U minus 75 divided by 3. So all I'm going to do is use this to write out these 4 angles. So where I had U, I've got this angle here, so that's going to become, I'll put it in brackets, A minus 75 over 3. Here I've got 360 minus A. I'm going to put this angle in bracket because that's my U value, and I need to minus 75 from that U value. Now for this one, so my U3 is 360 plus A, but I need to minus 75 from that U value. And finally, for my last value, I've got 720 minus A, that's my U4. So this now would be U4 minus 75 and divided by 3. So even though that looks complicated, can you imagine how much more complicated it would be if we'd started using the actual value of A, this 77.160? It would look a hell of a lot worse. So now we just need to go to our calculator, use our stored value of A, we're not going to get any rounding errors, and just plug these in. And we should find. Okay, so we've almost done, but we need to do one final check. So just to be sure, this is theta now equals all of these. We're checking our original domain. Do you remember we said we didn't know if this U4 was in front of 615 or after? Likewise, we could have seen from here that it wasn't. 720 minus A, that's 720 minus 77, that's going to be about 640, so it's definitely out of range. If we didn't spot it here and we went on to work it out, we could also have another chance of spotting it, and always do this as your final check. Look at your domain. Are all your answers between 0 and 180? And we can see here that our final answer isn't. So this one here is not an answer. And we've got 3 solutions here.